Radical equations. All right, so our objective for this video lecture, we want to solve radical equations both algebraically and, of course, graphically. So let's begin by recalling what we already know that's going to be useful for this lecture. We know that inverse operations undo one another, and we use this fact to solve equations. So for example, given the equation x plus 5 equals 6, the operation we have here is addition, x plus 5 equals 6. The inverse operation of addition is subtraction. So we use the inverse operation subtraction. We do that to both sides to undo the addition. Subtract 5 from both sides. There we have a 0, and we wind up with x is equal to 1. Okay, so let's talk about inverse operations a little bit. When we're dealing with radicals or exponents, inverse operations are as follows. Squaring and taking the square root, those are inverse operations. If you square both sides, that undoes the square root. If you take the square root of both sides, that undoes squaring. Similarly, cubing and taking the cube root, etc., etc. Okay, so what's a radical equation? A radical equation is simply an equation with a radical. So it has a square root, which is the most common radical, or a cube root, or a fourth root, or a fifth root, etc., etc., etc. A radical equation is an equation with a radical. And as we talked about right up here, we get rid of a square root by squaring, because squaring and taking the square root are inverse operations, a cube root by cubing, etc. Now, warning, squaring, cubing, etc. can sometimes create extraneous solutions. An extraneous solution being a solution that doesn't work in the original equation. Okay, so as usual, as always, we want to check, okay? As I've talked about in previous video lectures, when you're solving an equation, you never ask, am I right? Because you know whether or not you're right, you check it, and you find out whether or not you're right. So we want to do the same thing here. I have two solutions, am I right? Well, check your two solutions and find out. Okay, so what's the procedure for solving a rational equation algebraically? Well, the first step, isolate the radical on one side of the equation. Okay, step 2, now that the radical is isolated, we're going to use the inverse operation, squaring, cubing, etc., to both sides to undo that radical. And then step 3, continue to solve as necessary. We've been through this. We simplify, separate, solve, and check when we're dealing with just the equation. Okay, I've got a couple of examples for you. Let's take a look at our first example. Solve the cube root of 2x minus 4 minus 2 equals 0 algebraically. Okay, I'll slide up here so you can see what I'm into with these steps. First things first, isolate the radical, of course, as necessary. Well, here's the negative 2 hanging out. That's not part of the radical. So let's add 2 to both sides. So now the left side is the cube root of 2x minus 4, and the right side is 2. Okay, so we zeroed this out. We isolated the radical on one side, in this case on the left side. Now we know how to undo a cube root. We undo a cube root by cubing. So we're going to cube both sides. Okay, well, cubing a cube root undoes it. So we're left with 2x minus 4 on the left, and 2 cubed is 2 times 2 times 2. Remember, cubed means multiply by itself 3 times. 2 times 2 times 2 is 8. So we're here, and now we have a simple linear equation. Left side is simplified, right side is simplified. So now let's separate. Well, I only have one variable term, so I'll shift the constant term over to the right. 2x is equal to 12, and now I'll solve by dividing both sides by 2. There's a 1 on the left side, and I have the solution x is equal to 6. Or so I think. I always want to check. I think the answer is 6. Let's do our check, an algebraic check. We copy the original equation. So we have the cube root. Everywhere I see an x, I'm going to substitute 6 and see if these two things are the same. So 2 times 6 minus 4. Okay, minus 2. Does this equal 0? That's the question. If I put 6 in for x, wherever x is, do I get a statement that's true? I'll slide up here. That looks like a good calculator problem for me. Okay, let's see here. I think my calculator actually has a cube root function. Let's see. I do right there, number 4 under math. I can do a cube root. I can do, if you see number 5 here, I can do any root I want, but it does have a cube root shortcut. So the cube root of 2 times 6 minus 4, I'll come out of that by using my arrow key, and then I subtract 2. And do I get 0? And the answer is yes. I get 0. So on the left side I have 0, on the right side I have 0. I feel good about my answer because it worked in the original equation. Let's solve this one graphically. Okay, well, you'll notice, let's notice here that we already have an equation equal to 0, so we can just find our zeros or find our roots. So we'll just use y1. y1 is equal to the cube root of 2x minus 4, and I subtract 2 outside of that. Okay, so that's y1, and of course now I want to do calc 0. I think it's 0, is it zeros? I forget. Calc 0. Okay, and then of course left bounds, right bounds to find the 0. We think it should be at x equals 6. Let's take a look. Let me shift my paper up. Okay, so graphically solving this, let's go y equals. I already have it cleared. So again, the cube root, I'll use my shortcut if I can find it. That's not a second key. Okay, let's quit out of that. It's just math, and there's my cube root. So I have 2x minus 4 under the cube. Whoops, I'm not putting it where I'm supposed to put it. Let's go to y equals. Sorry about that. Okay, y equals the cube root. I was in the wrong place. Okay. Under the radical, I have 2x minus 4. 2x minus 4. Come outside of the radical to subtract 2. Okay, again, because it's already set equal to 0, I'm going to graph that. I'm not sure what my window is, but here comes my graph. Okay, that's an interesting graph. Let's go to my standard window here. So let's go to Zoom Standard. Here it comes in from the left, comes up, looks like it crosses over there, and then it keeps going above the x-axis. So somewhere in here is where the 0 is. So second calc 0, number 2. And I'll move my cursor. I know that this is to the left of the 0, so I'll press enter. I'll go to the right of the 0, somewhere over here, and I'll press enter. Ask it to guess. Let's ask it to guess again, because mine's not doing it for some reason. Okay, well mine appears to be not working. I'm going to try it again. So let me turn it off, and I'll turn it back on. Go to y equals. I'm good there. Let's graph it. I've got a graph. Let's try again. Whoops. Second calc 0. Okay, left bound is to the left side of where I think the 0 is. Right bound is to the right side. And let's take a guess. There we go. So it says when x is 6, that's a 0. X is 6 right there. And that's what we were looking for. When x is 6, this gives me a 0. Okay, so that just did a check there for us graphically, or we solved it graphically as well to find that x is equal to 6. Okay, one more example. This example, as you might imagine, is going to have an extraneous solution. Let's take a look. Solve the square root. Let's remind ourselves that when there's no number up here, it's assumed it's a 2. So this is the square root of x minus 1 equals x minus 7 algebraically. Okay, first step, isolate the radical. It's already isolated. It's over here on the left side by itself. So let's undo it. Let's use the inverse operation, in this case of square rooting. So we're going to square both sides. Squaring undoes square rooting, so the left side is x minus 1. On the right side, it is x minus 7 squared. I'm going to write that out. X minus 7 squared is x minus 7 times x minus 7. Okay, so now we need to solve this. Well, the right side needs to be simplified. Left side x minus 1, right side is multiplication, x squared minus 14x plus 49. Okay, it's obvious I have a quadratic. We solve a quadratic by setting it equal to 0. So I'll subtract x from both sides. I'll add 1 to both sides. And I'll have x squared minus 15x plus 50 equals 0. Okay, so now our quadratic is set equal to 0. Can we factor it? Okay, and as you remember here, we've done some with our factoring, like a factoring grid here. Okay, we know we're looking for x squared here, and we're looking for plus 50 here. So we know it's going to be x times x. So this is x and then x. Okay, and we want to make a positive 50, and we want this in here to come out to be a negative 15x when we add it together. Well, I've already done this, and I know that if I do negative 10 and minus 5, negative 10 times negative 5 is positive 50. Negative 10 times x is negative 10x. Negative 5 times x is negative 5x, and negative 5x and negative 10x is negative 15x. So this is minus 10 and minus 5. So I now use my zero product property. Either this is equal to 0 or this is equal to 0, which means x is equal to 10 or x is equal to 5. Okay? So those are my two possible solutions. We want to remember one of these might or both, they might be extraneous. When we square both sides or cube both sides, you might wind up with an extra solution because of the squaring process or cubing process. So let's check. Okay, let's check x equals 10. Here's the original. Okay, x equals 10 means the square root of 10 minus 1. Everywhere I see x, I put 10. Is that equal to, question mark, 10 minus 7? Well, 10 minus 1 is 9. This is the square root of 9. Does that equal, question mark, 3? Well, sure. The square root of 9 is 3. So it appears that 10 is indeed a valid solution. Let's check 5. Okay, x equals 5. Okay, so back up to the original. The square root of 5 minus 1. Does that equal 5 minus 7? Okay, so 5 minus 1 is 4. Does the square root of 4, equal 5 minus 7, which equals negative 2? Well, that's never true. The square root of a number is always positive. The square root of 4 is 2. 2 does not equal negative 2. So 5 is not, even though it came out algebraically, it is not a solution. It is an extraneous solution that came out algebraically. The only solution to this radical equation is x equals 10. Okay, so there's an example of an extraneous solution. Let's take a look at it graphically. Well, if we look at our equation, we have a left side and a right side, so we might as well do a y1 and a y2 and find the points of intersection. So graphically, we'll do a y1 is equal to the left side, the square root of x minus 1. And we'll do a y2 is equal to the right side, which is x minus 7. Okay, I'll shift this up. Let's bring the calculator out. Okay, go back to y equals, clear this out. y1 here is the square root of x minus 1. And y2 is x minus 7, which we know that's just a line. Okay, let's graph that. There's the square root of x minus 1, and here comes x minus 7. And it appears they cross over here in quadrant 1. Let's just do a quick window. Let's go a little bit further into quadrant 1. So I'll max my x at 20 and take a look. So there's the square root of x minus 1. Here comes the line x minus 7. They clearly only intersect at one location. It's right here in quadrant 1. Where is that? Where is that intersection? Second calc, intersect. Excuse me. Okay, I always kind of go close. Is that the first curve? Yes. Second curve, yes. Would you like me to guess? Me, the calculator, yes. They intersect at 10. At x equals 10 right here, and y equals 3. And that's what we came up with here, that 10 is a valid solution, and they intersect with what the value is 3. Notice again, when x equals 5, if I do a trace, x equals 5, they do not intersect. So that is if you look up here again, they do not intersect at x equals 5. This is an extraneous solution that came out algebraically but is not truly a solution. So there you have it, solving a radical equation. The big piece here, two big pieces here: isolate the radical on one side before you undo the radical, and number 2, be aware of possible extraneous solutions. Always do a check.